Alright, so these are all the formulas that are in that picture up there in the top. You can click on that picture to get a much better view of the formulas, and it's a lot easier to read if you click on that picture and blow it up. Alright, so this you have. I'm going to show you a few other tricks that you need to remember that they're not going to give you. All of this will be given to you on the SAT, but I'm going to give you a couple other tricks that they really like to use in the questions, and they won't give you those tricks. So here we go. So one of the tricks uses another special triangle that's not given to you, and typically they'll give you something here like 3 and something here like 5, and you can use the Pythagorean theorem that's given to you to calculate this x. That Pythagorean theorem was this formula. So your C here would be 5, your excuse me, your A would be your x, and your 3 would be your B. And you could run that calculation and get 4. But it's a lot easier if you remember that this is a special, what's called a 3, 4, 5 triangle. And a lot of times they won't give you something simple as 3, 5, and x and ask you for x. They'll give you 3x, 5x, and maybe 2x, something like that, and ask you to calculate excuse me, what x actually. They probably won't even give you that. What they really like to do is this. Just give you those two and ask you to calculate the value of x. Given a particular perimeter of the triangle. So I'll just say the perimeter of the triangle is 24. What's the value of x? Well, you need to know that this is a 3, 4, 5 triangle, so this side's 4x. And then you can come in here and add all three of these. So 3x plus 4x plus 5x is 12x, which is the perimeter. So 24 equals 12x. And then you divide both sides by 12, and you get x equals 2. They really like to ask questions like that. So this 3, 4, 5 triangle is one you really need to understand. And it doesn't necessarily have to be 3, 4, and 5. It can be multiples of 3, 4, and 5. So, for instance, 6, 8, and 10. Because that's 3 times 2, 4 times 2, 5 times 2. 6, 8, and 10 would work. It can be 9, 12, 15, and so on. This is still a 3, 4, 5 triangle because this is 3 times 3, 4 times 3, 5 times 3. It's the 3, 4, 5 times the same number. So it's still a 3, 4, 5 triangle. Another one they like to do that they don't tell you in the beginning is similar triangles. And you can see that these are two different size right triangles. Here's a right angle, here's a right angle. This angle is x degrees, this angle is x degrees. And that might be all the information you get, other than maybe the measure of one of these sides or something. But you need to know that the three interior angles of a triangle add up to 180. So you've got 90 plus x plus whatever this is 180. And on this one, 90 plus x plus whatever this is 180. So all the angles inside these two are the same, even though the measurements might be a little different. So what you'll probably get is something like, they'll say this side is 10, and this side is 5, So this side is 4 maybe, and what's the value of y, which is the measure of this side? Well, since there's similar triangles, you can set it up as a ratio. So 10 is to 5. The same way that y is to 4. Now you could have done this the other way and did 5 over 10, then it would be 4 over y. You just have to make sure you keep the same numbers. You keep the numbers from the same triangle on the top and the numbers from the same triangle on the bottom. Otherwise it's not going to work. Then you cross multiply. So you get 5y equals 40, and you get y equals 8. So that's similar triangles. More than likely, they won't give it to you this simply. A lot of times this x here will actually be this angle, in which case you kind of have to redraw that. So you would redraw this triangle so that it's situated the same way. So for instance, if x was this angle instead, I might take this out really quick. Alright, if x was this angle instead, this triangle actually we could redraw it like this with x right here and the 90-degree angle here. That means actually this side's the 4 and this side's the 5. So when you go to set up that ratio, it's going to be 10 is to 4 as y is to 5. They like to do that a lot because they like to trick you. Excuse me. Alright, and the other thing they like to do with this, with the similar triangles, is they like to take this triangle here, and I'm just going to get rid of it and redraw it. They like to put it somewhere right in here. And so basically you just have a triangle. Basically all you've got is a triangle, big triangle, with a line straight down right here. So in all actuality, you do have similar triangles because you've got the right angle there, the right angle there, same angle here, because they share this same little section here. So it has to be the same angle because it's the exact same thing. And they'll give you the length of, maybe this is 4. And then somewhere in the problem they'll say that this line bisects this line. So that would tell you, since this whole thing is 10, that this side's 5 and this side's 5. So you would set this up the same way, like this 5 is to this 10, because it's this side of the small triangle to this side of the big triangle. The same way that this side of the small triangle is to this side of the big triangle. And you solve that the exact same way. So that's similar triangles. Now there's one other thing I wanted to show you, and it has to do with angles. First of all, they'll tell you that this line and this line are parallel. And I tried to draw them as parallel as I could so that it looks right, but they'll tell you those are parallel. Now, because those are parallel, when this line is drawn through here, that means, and I'm just going to decide that this angle right here is 30 degrees. Oops. So 30 degrees. Alright. So because these are parallel and this line intersects, that means this angle is 30, this angle is 30, and this angle is 30. That's always going to be true. As long as these are parallel and that line intersects, all those will be the same. What's also true is, since this is a straight line, that means from here to here is 180 degrees. That means this angle right here is 150, which means this angle is 150, and this angle is 150, and this angle is 150. So that's how that works. We like to use that a lot. And what they'll do is they won't give you all that stuff. You'll get something like this, and then probably something like this, and then you'll get like an X right here maybe. And then they'll tell you that this line bisects this angle. Bisects just mean it cuts it in half. And they'll want to know what X is. Well, because you know, since this is 30, this is 30, this is 30, and this is 30, and that bisects that angle or cuts it in half, that means X is 15 degrees. So that's how you do that one. And it's also possible, usually they'll set it up with these two lines that are parallel, but it's also possible that you'll just get something like this without the parallel lines. But in that case, the same thing is true. Because that's 30, that is 30, and that is 150, and that is 150. It's still true. So you can use that to solve some problems with angles fairly quickly. Alright, I hope that helps. If you have any questions about anything in this video, please feel free to leave a comment, or you can use the contact form over on the right to ask a question, or you can email me directly at andrew@avmathcoach.com. I'm also on Facebook at Andrew Vickery, Math Coach. I'm on Twitter at avmathcoach. I'm also on YouTube at Andrew Vickery Math Coach. Thank you, and I look forward to hearing from you.